vibrations. Part 1. Waves. They transfer energy from one place to another, but they don't transfer any matter. For example, this is a phone. The light waves comes to our eye so we can see the phone, and the sound waves comes to our ear so we can hear music and everything. Sometimes we can interpret that energy as meaningful information. This is called displacement. How far from the equilibrium point the wave has oscillated. The distance means how far the wave travels from its starting point. The maximum height of the wave is called an amplitude, and the distance of one entire oscillation called a wavelength is the crest. But the opposite side of the crest is the trough. Now, this is the frequency, that means hertz. That means number of oscillations completed per second. This is the time period. And imagine the time period is 0.5 seconds. And compared to 1 second, how many oscillations will it make? That means the answer is 2 oscillations per second. So that means 2 oscillations per second equals 1 second slash 0.5. This here you can change the other. You can change T and F in the other way, like this. T equals 1 slash F. That means then here it says 4 oscillations. That means the frequency of the wave is 4 hertz. So that means 1 second is from 4 hertz equals to 0.25 seconds. And after that, imagine this is 400 hertz. 400 hertz. This is the speed, frequency, and the wavelength. Now the wavelength is 70 centimeters. How small is that? Now you had to divide that 70 centimeters with 100, and then it will be the answer of 0.7 meters. Then multiply it by 400 hertz, which makes 280 meters per second. So that means the speed is 280 meters per second. Now these are two types of waves, the transverse and the longitudinal. Number 1, the transverse. That means they have oscillations that are perpendicular to the direction of energy they transfer. Transverse waves are waves, for example, electromagnetic types like light and sound waves. Ripples or waves, you can call them any way you want. And the waves of strings, like example for a guitar. Now number 2, the longitudinal. They have oscillations that are parallel to the direction of energy they transfer. Some parts are spread out and some parts are compressed. Those waves include radio waves and seismic P waves. So I hope you like the video. Subscribe for more videos. Hope